Hi everyone, that's Artemakis here. Welcome to the lecture on Infrastructure as Code, Redefining IT Automation. Here's what we'll cover today. We'll start with an introduction to infrastructure automation, exploring its significance and benefits. Next, we'll discuss the evolution of IT infrastructure management, highlighting the transition from traditional methods to modern practices. We will then delve into the key concepts of infrastructure as code, focusing on its foundational principles and methodologies. Following that, we'll cover best practices for implementing IAC effectively, ensuring security, scalability, and compliance. We'll also look ahead at future trends in infrastructure automation, examining emerging technologies and their potential impacts. Finally, we'll conclude with a summary. Let's dive in. Infrastructure automation involves using technology to execute processes and tasks with minimal human intervention. It's crucial in modern IT as it enhances efficiency, consistency, scalability, and traceability of changes. The key benefits include reduced manual errors, faster deployment times, traceability of changes, and the ability to manage complex environments effectively. Now, let's discuss about the evolution of IT infrastructure management. Traditionally, IT infrastructure management involved manual processes and physical setups, which were error-prone and time-consuming. These methods often led to potential inconsistencies, slow deployment times, and a lack of scalability. Infrastructure as code, also known as IAC, has emerged as a game changer, allowing infrastructure to be managed through code, bringing software development principles to infrastructure management, thus leading to the concept of DevOps. Now let's discuss about the key concepts of infrastructure as code. As the name implies, infrastructure as code is a methodology where infrastructure is described using code. In infrastructure as code, there are two main models: declarative, which specifies the desired state, and imperative, which outlines steps to reach a state. Also, by using version control systems, teams can collaborate, track changes, and roll back to previous configurations if necessary. Moreover, idempotency ensures that operations can be applied multiple times without changing the outcome, making infrastructure deployments predictable and repeatable. Last but not least, infrastructure as code provides comprehensive traceability of changes. Every change to the infrastructure code is recorded in the version control system, allowing teams to track who made changes, what changes were made, and when. This transparency is crucial for debugging issues, auditing, and maintaining compliance. Now let's discuss about some of the main best practices for when implementing infrastructure as code. When implementing IAC, it's best to start with small, manageable projects and gradually scale. Also, modularizing and reusing code helps maintain clarity and reduces redundancy. Moreover, security and compliance should be prioritized, ensuring sensitive information is protected and infrastructure adheres to regulatory standards. In addition to the above, thorough documentation and active involvement in the IAC community can provide valuable insights and support. Last but not least, the traceability provided by infrastructure as code can be used to maintain a detailed history of infrastructure changes. This capability is invaluable for auditing purposes and helps quickly identify the root causes of issues by reviewing the history of modifications. As we look to the future, infrastructure automation continues to evolve, driven by advances in technology and changing industry needs. To this end, we can definitely say that AI and machine learning are playing significant roles in predictive analysis and optimization. Also, infrastructure as a service, or IaaS, and serverless computing are gaining traction, offering more flexible and scalable solutions. Moreover, as automation becomes more widespread, the focus on security and compliance will intensify, ensuring safe and regulated environments. Lastly, the concept of NoOps is emerging, where infrastructure management becomes fully automated. Additionally, automated governance frameworks are gaining traction, thus offering more efficient and secure operations. In conclusion, infrastructure as code has already revolutionized IT infrastructure management by introducing automation, consistency, and scalability into the process. In this lecture, we discussed the evolution of infrastructure management, the foundational concepts of IAC, and best practices for its implementation. By embracing infrastructure as code, organizations can achieve faster deployments, reduce errors, and maintain compliance and security. Looking forward, trends like AI and serverless computing will continue to drive innovation in this space. Thank you for watching this lecture. For more insights on automation, AI, databases, programming, and tech trends, subscribe to my channel on YouTube. See you next time.